connected. Sorry, so I can see there's a motor connected here. If I had the sensor, I could see the sensor and also the feedback from the sensor.
Is it Bluetooth now?
Yeah, it's Bluetooth Low Energy, Bluetooth 4.0.
Okay. Is it working on the Android or only on the iPad?
On iPad, Android, macOS, and Windows 7 and 8. For Windows 7, you need a dongle because Windows 7 doesn't support Bluetooth. And then here we can do the programming part. So we can do very simple programming. So just turn on the motor at power 2, for example, and that's very simple build. But in this activity, we also want them to learn about more advanced programming concepts. So what we've done is a program where they're going to use a variable. So here they are going to store a value in a variable. So we start by storing a value of 1. And then we are going to introduce loops so that they can learn about iteration. And at each iteration, we are going to add 1 to the stored value. So if I just do that, we can see the value incrementing at each iteration. So now what I want to do is use that value as an input to the power of the motor. So what I'll do is take my motor block again, my motor power block, put that inside the loop, and then instead of adding 8 as an input, I will use the variable as an input. So now at each iteration, the value is going to increase for the motor. So just to have the right timing, I'm going to wait 2 seconds, and then at each iteration, it will shake for 2 seconds. So now I can put my house here and start, the experiment. So at magnitude 2, it's still holding, and then at magnitude 3, it's still holding. Magnitude 4, now it failed at magnitude 4. So now with a building of the same height but a different base, I'm going to try the same here and then run it again. So again, magnitude 1 it's holding, 2 holding, 3 still holding, 4 still holding, 5 still holding, 6, 7 it failed. So now this one fell at 4, this one fell at 7, and we did the experiment just once. So in the classroom you would probably run that experiment 2, 3, 4 times. You could use a graph paper to record the experiment outcome. So start implement more and more science practices, show them how to draw graphs and so on.
Can you have several variables or only one? Can you name that variable?
Yeah, right here we can have only one variable.
Okay.
So that's a very simple way of introducing variables. Yeah. If we wanted to have more advanced programming, you could use Mindstorms, for example.
Yeah, okay. Is this compatible with Mindstorms, the programming interface?
So the bricks are compatible because it's Lego bricks, but the system is different.
Okay.
The plug, this is the new power function plug, so it's not compatible electronically wise. So that would be the way we introduce science, and we have other activities for biology with the frog and pollination. We have activities on exploring forces and speed, things to prevent flooding, so looking at hazards, natural disasters, and then sort to recycle, so something about recycling and managing resources.
Do you have lesson plans in different languages, or is it only English?
No, we have them right now. I think it's in, well, I'll just check that. So we have them in these
Swedish
languages, and then it will be in 15 languages, including Portuguese, Arabic, Chinese also, and not Turkish. So that's something we
Can you change the language when you're in a project? Yeah, let's say you have kids from like refugee kids.
So you would have to change. So in the same application, you have all the languages, but you need to go out of the project to change the language. So right now, for example, I'm in English. If I switch to Danish, for example, then I can start the same project and use it in Danish.
But if you have been working for 20 minutes, so you have been doing stuff, can you go and change it and go back to the same?
Yeah, the same project. Yes. Yeah. So just to show you, like here, well, that was my project. So if I write something in,
yeah, okay.
Well, if I write
Let's
hello,
yep.
you know, then I can go back to the lobby and switch to another language. So if I want to try in Korean, for example, now I can reopen that project, and now I have the instructions in Korean.
Yeah, okay.
But all the things that I have inputted are still there, and the same for my program. It's still there. So that's the way we can switch and use that to kind of check the language or.
Yeah. Can you also record things?
Sorry?
Can you also record things?
Yeah. So that's a sound recorder. So I can record the sound. And then stop
tell
it.
about your project.
Yeah,
that's
explain.
more. So that sound is to be used in the program. So what we've seen is that children like to use sounds in the program, and
so they have it. If a trigger sets the sound.
Set the sound.
Yeah,
so
okay.
the sound that I just recorded. Well, we can't really hear with the noise here, but we can reuse this sound as a sound number 21 in the program.
Okay, but you can't put the sound files in the documentations.
No, not at the moment.
Oh, okay.
Does it have a sound?
No, it has just a simple beep that we use when we connect, but we're not controlling the sound at the moment.
So there's no speaker module. The sound is coming from the iPad.
From
Okay.
the iPad or from the
Okay.
device.
Okay. Do you have a microphone module so you can pick up sound?
No,
a certain
the sound
threshold?
also is coming from the device.
Ah, okay. Okay.
They have much better sound recorder than we can build
Yeah.
here.
Yeah, but you can have like sound switch, or if it senses a sound, then it can trigger something, or.
So well, we can use that sound trigger from
okay.
the iPad. So for example, if I want to wait for a sound level to be high enough and then do something, so for example, I wait for the sound and then run the motor. So here with the execution highlight, well,
but it's only sound pressure level. It's not certain frequency or something.
Yeah, it's just
okay.
sound pressure.
Okay.
What other blocks do you have?
Sorry?
What other things do you have?
So it's the action block, so that's to make the motor move in one direction or the other, to stop the motor, to run the motor for a certain time, and then to set the power. This one is to change the color of the LED, so what I like to do with this one is to make it flash. So for example, I can take two colors, so I can take a red one and a blue one. And now it looks like a police car.
Oh, okay.
So like that you can set a different mood, and you can make longer sequences. So if I select green, so now I have 3 colors. So you
can you run them simultaneously, so you can get white if you have a full.
I can,
the intensity level.
No, we only have one intensity for, for the color.
And you are using the same application for the whole grades, right? For the 2nd grade, 3rd grade, 5th grade, 6th grade, everybody.
Yeah, right now we are recommending it for 2nd and 3rd grade. So that's the application we have right now is 2nd and 3rd grade. But you can go much further on the programming side if you want. So that system we can plug up to 3 hubs. So for example here I have 1 hub connected. I can turn on the second one and plug the second one up. So now I have 4 I/O ports. So I can control 2 motors and also 1 sensor. So for example here what I can do is well, instead of using a variable to control the speed, I can use a distance sensor. So I will put my motor here, and then here I have a distance sensor. So I will use that distance sensor here as an input. And to start that in parallel I send a message like that. So by doing that, I'm sending a message, and then if I put my hand on top of the sensor, it's changing the speed. And you can see here the value is 0. So if I remove my hands, now it's 6. So I can change the speed like that for the motor and so on. So, and now each time it's going in front, it's going to slow down a little bit for a few seconds. And then if I put my hands, now I'm stopping the wheel. And you can see here the two motors are synchronized, but we have also a mechanism to control just one motor at a time. So what I can do is...
Det måtte man jo ikke inden, det var teori på det, men hvor I bygger, der er det mest naturlige ting i verden, ikke også?
Just not that. So what I can do is do a long press here, and now we have colors appearing here, and now we have a red and a green motor, so to know which one is which one.
So you can address one of them.
Yeah, and I can address one of them. So now I'm only addressing the red motor, so it's this one, and so when I turn on, so this one is not turning anymore, and then I can use that as a remote control. So I can put that, 10 meters from the iPad, and use that as a remote control for the motor, for example. So that, and you can connect up to 3 hubs, so that would be 6 motors or 4 motors, 2 sensors. So you can do fairly advanced models with that. And also we are providing a design library. So this design library is made to inspire kids to find their own solutions. So we provide 15 different modules with different functions. So this one is a claw. I'll just switch back to English just to get the right names. So we have a spin module, a crank, a walk module, a spin again, a flexing module, wheel, a lift, and a grab module. So for these functional modules, we are providing the building instructions and also the programming instructions. What we also provide, so let's go back
could you as a teacher turn off the instructions if you want them to try out themselves, the students?
Well, we are providing these modules, these instructions here, but then for the inspirational model, we are not providing the instructions to do exactly what you said, to let them think by themselves and find their own solutions.
Yeah.
So, but still, these parts, for 7 years old, we have estimated that it's important to give them the building instructions. But here they can work from just the pictures, but give them enough details so they can have an idea. But then they don't have the instructions, so they have to find by themselves the solution.
Yeah. But if you could turn that on and off, you could have the same lesson plan for older kids as well, and say they don't get the whole instructions. They have to think themselves.
Yeah, that's interesting. I'll bring that to the team.
Yeah.
I think it's
and maybe if you, like, the teacher turns it off, they have to try themselves for 5 or 10 or 15 minutes.
Yeah.
If they can't make it, then you can turn it off. So then you can have a different progression level.
Progressions,
Yeah.
Yeah, that's interesting. So we also have open projects that are more advanced, where basically we give a brief to the student, and then some inspiration modules they can use, but that's it. So now they have to find their own solution. And in the teacher guide, we explain to the teacher what kind of conversation they can have to make sure that the students, get a real science learning out of that, so that they would be able to argument why they have chosen one module over another one, and so on. So that's really the idea, is to...
and they can do that in the documentation. They can write their...
they can write their own arguments.
Yeah,
they can have a discussion also in the class. And, so really the idea is that they start with the guided project, so they learn... Well, sorry.
But do you have any kind of teacher dashboard so you can log in and see your...
No, not at the moment. So what they can do right now is they can share their report in a PDF format, so the teacher can get all the format, and also if they already have a classroom management system, they can upload that to the kids' portfolio and so on.
Okay.
That's the recommended use these days.
Okay.
So yeah, that would be. So we have these getting started activities to learn about the system, to start simple programming, do some collaboration tasks. Then we have a guided project, which are step-by-step science inquiries, and finally the open project that are like design and engineering briefs, where they can find their own solutions. So with all these activities, we estimate there's more than 40 hours of activities and science activities for the classrooms.
But do you have account management, so you can, each student can create their own account? So you divide.
That would be made by the operating system. So on iOS.
Oh, that's the problem.
Yeah.
We have to wait to the next. But then they have to have their own iPad. Because otherwise some other kid will just go in and destroy it, or just see what the other
and Apple
did.
just announced that they are.
Yeah, they did. Let's see.
I don't know when they are coming.
It will be probably this year, but I don't know why and when or how they will implement it.
Oh yeah,
we'll see. Okay, interesting. Yeah.
You're welcome.